Well, here are the answers for the review questions for exam 4. To find the force, you got to find the difference in pressure multiplied with the area. Of course, it has to be in pascals. That's why you have multiplied with 10 to the 5 that you see here. This question based on Pascal's principle. You're asked to find the smaller force, so rather you got to make that the subject. And the area of cross section is pi r squared for each one. On making force the subject, you get 942 newtons. But that was not required, so I'll rather take it out. Now in this question, since the boat is floating, the mass of the boat should be equal to the mass of the water displaced. And V is the volume of the boat. Only 69% is underwater, so the volume of water displaced is 0.69 times the volume of the boat. Now once you get the volume of the boat, you know that as you keep loading sand, the whole thing is going to get submerged. And so the maximum mass of water displaced, which is volume times density of water, would give you the maximum mass of sand. I mean the maximum total mass. And since the boat already has a mass of 50 kilograms, the mass of the sand is 22. And in 4, the apparent weight is equal to the actual weight. Take away the buoyant force, and the buoyant force is the weight of water displaced. Now, so you can find the weight of water displaced. And since we know that the weight of water displaced is volume of water times density times acceleration due to gravity, you first find the volume of water using mass divided by density. And so the density should be the mass divided by that volume. 1039.3 kilogram per meter cube. In this case, the tension in the string is the weight acting down. Take away the buoyant force acting up. .84 newtons. First, you have to use the equation of continuity to find the velocity. And you get the velocity, and then you can use Bernoulli's principle. It's a horizontal pipe, so you do not need the potential energy term. That's P2 by density, so P2 is that multiplied by density, 4005 pascals. 7, time period of oscillations. Square both sides, rearrange to find K. 8, the total energy of an oscillator is 1/2 Ka squared. Omega is square root K by mass, so K is m omega squared. Plug that back into that in place of K. Make omega squared the subject. Find omega, and from there find the frequency, because frequency is omega by 2 pi. Nine. That's a formula for damping. Gamma is the damping coefficient, which in this case will be the same in both cases. So set up two equations. Divide 2 by 1, and the exponential terms get cancelled, and solve for the amplitude. 10. That's the time period of a simple pendulum. Set up two equations. The length of the pendulum is the same. And square both equations and then divide one by the other. That gets rid of the square root sign. Give 6.55 meter per second squared. Linear expansion. Straightforward question. 12. Heat lost or heat gained is mc delta T. So you need that much heat, but this heater can produce 67 joules per second. Therefore, the time would be that divided by the power, 92.55 seconds. 13. Heat lost is equal to heat gained. Heat lost by water is equal to heat gained by aluminum. (35.30°C). 14. Formula for conduction. Four times 2.4 is how you find the area. So you get 499.2. That is in 1 second. And since you got to find it in 1 hour, multiply it with 3600, gives 1.79 megajoules. 15. Quantity of heat radiated. First find the area of the filament. That's Stefan's constant. Emissivity is 1. After you get the area, remember that we're talking about the surface area. So it's circumference 2 pi r times the length. And, so you rearrange to make length the subject. We're calculating the length of a filament inside the bulb. Get 5.86 centimeter. 16. The ideal gas equation. Use that to find the number of moles. And since we know the molecular mass, multiply this with that molecular mass in kilograms to get the mass as 1780 kilograms. 17. Root mean square velocity is square root 3 RT by the molecular mass. All of the factors being the same, root mean square velocity is proportional to the square root of the absolute temperature. Make two equations, divide one by the other, square both sides, make T the subject to get 1172 Kelvin, and in Celsius that would be 899 degrees Celsius. 18. The work done during an isothermal process. Assuming that it's only 1 mole, that would be the work. Now we got to find out the number of moles from the given information. It is 1.92 moles, and therefore the work done is 3327 joules. 19. Again, the work done during an isothermal change. Straightforward, direct question. Efficiency of any engine can be found out using work over QH. That gives QH 12.3 kilojoules, and so the efficiency is 0.35. 21. Coefficient of performance of a refrigerator is QL by work. So the work is QL by COP, and you get 6.9 joules. But again, work is QH minus QL. So the heat absorbed from the freezer is 6.9 joules, but the heat rejected to the atmosphere is 14.86 joules. And last question, the change in entropy is dQ by T, 600 joules leaving, actually 600 joules leaving that, so you get 1.04, should be negative. because heat was leaving the system. And for the other one, heat is entering the system, so the entropy goes up 1.27. So the net change is positive 0.228 joule per Kelvin. Thank you and good luck.